Hi again, this is Tor from IDCOM. Today we're going to talk about the role of artificial intelligence in maintenance. There's a lot of different perceptions out there, in my opinion. Some people feel like they can just buy a black box and all their problems will go away. And some others really don't think there's a role for artificial intelligence in maintenance, and everything in between. So the video today is a little bit different. It's an interview. And therefore, since it is about, I can't remember exactly, about 25, 30 minutes long, I will have some time markers down below here so you can kind of see the topics we talk about. If something interests you a little bit more than something else, you can jump around a little bit in the video if you don't have time to watch the whole thing. And IDCON is not a artificial intelligence, we're not artificial intelligence experts, right? So we have invited a world-renowned expert, and it is Eitan Vesely. He's the Director of Artificial Intelligence at SKF. Let's go to the interview. Hey, Ethan, welcome to this little video.
Thank you, Tor. Happy to be here.
Great. So why don't you tell us a little bit, who you are and a little bit what you do day to day.
Sure. So as mentioned, my name is Eitan Vesely. I'm based out of Israel, and I'm Director of Artificial Intelligence in SKF. So pretty much in charge of commercialization of AI technology. Prior to that, I was the CEO and the founder of an Israeli startup called Presenso, a software company that most of it were data scientists, AI experts, and our solution was a predictive AI-based predictive maintenance solutions. For most of it was for the rotating equipment or the process industry in general.
Okay.
Maybe one more line about myself: mechanical engineering background, and then I did start my master's degree in computer science. Never finished it as we started the company, but this is how both worlds are merged.
Right. Okay. Yeah. Interesting. So you actually know machines as well. That's good. So it's not just
Machine and machine learning. Yeah.
Yeah, that's good. Good. So I don't know much about artificial intelligence, but we're trying to make sense of it here, like day-to-day maintenance. And if I understand it right, like artificial intelligence, what I've been taught is kind of three branches. You have like the robotics, the natural language processing, and you have something called like machine learning. I don't know, is that how you divide it up too, or does it make sense to you to do it that way, or
Uh,
it's like all these different words are all jumbled up?
yeah, maybe a disclaimer first. I'm not a data scientist per se, so I know how it works. I know how we can use it and bring it in and capture value using it, though I'm not the guy who sits and does the coding and the research and development.
Right.
When I think of artificial intelligence, the main concept is that it's if you take a block diagram, like we engineers are used to be thinking about everything in block diagrams, there is an input and there is an output to that function block. And when we speak of general algorithms, it's kind of linear. The input and then the function, whatever happens inside it, and then the output. There is a one-to-one link, a unique link between the input and the output. When you think of AI, the output depends on the input, right? So if you have more inputs as examples to an AI algorithm, it will learn more, and the output will be dependent on the number of examples that you used in order to train the algorithm. So the algorithm is learning from historical examples.
Right. So we kind of jump into that. So what I'm used to, being as old as I am, you have a DCS system in a paper mill or something like that, right? And you put a vibration sensor and a temperature sensor on a gearbox or a motor or something like that, right? And then we put limits to it. It's like if it goes over those limits, beep, or give us a red alarm or whatever it may be, right? That's kind of the old way. So if you take that old way and now you're talking about machines learning, can you kind of draw a parallel there? Is
Yeah,
it super different, or is it just a little bit different, or
it's
tell me
different.
about
It's very different, and I will also add another disclaimer that I spent one of my roles before starting the company was an industrial automation engineer. So I used to develop these control systems and set these alarm thresholds, right? Upper control limit, lower control limit, SPC, statistical process controls, etc. The thing is that whenever you set these control limits for alerts, you hard code a number, or you have like 2 levels or 3 levels, doesn't matter. You hard code a number. And who says that that limit is applicable and the right limit if you look at 100 different types of assets with the same control system or with the same PLC logic that runs them? And then again, let's take the temperature sensor as an example. So I have a normal temperature condition of X, let's call it 20 centigrade, right? I have an upper control limit at 23 and a lower control limit at 17, plus minus 3. But it could take the temperature a week or 3 weeks to drift from the nominal 20 to the upper control limit of 23. And in this time frame of 2-3 weeks, while the temperature is slowly drifting, nobody will know until it already reached the upper control limit of 23. When we speak on machine learning, first of all, it does not require these fixed thresholds. We're talking about adaptive thresholds, which are set based on the historical and current behavior of the data. So if a machine learning model would have been built using, I don't know, a few months of historical data in which the temperature was around the nominal value, this is what the model would expect going forward. So the model is trained on historical data. The model is being generated. The rules are being set. And then when the model is running in production, it compares the real-time value coming from the DCS with the projected value coming or predicted value coming from the model. The model expects a 20, but suddenly it gets a 21 or 20 and a half or 21 or 22, and that's it. Anomaly has been detected. So we replace the need in process engineers setting hard-coded limits, or I wouldn't say replace, but we add another level of analytics on top of that. Mm-hmm. And we're able to do it in a much larger scale, in a much more customized manner per specific pump or per specific sensor. And this is where the main advantage is.
Right.
And one more comment to that, Tor, because it's important, and I kind of rephrased what I said. It's not replacing existing control DCSs or control system. It's another layer, usually another layer which is more scalable and is able to provide more insights.
I like that idea because I think a lot of people out there struggle a bit. You know, I have everybody from being super skeptical to it, right? Saying, okay, what do we need AI? It's just the new stuff. We don't need it. To it seems like the higher up the chain you go, they're just like, oh, I'm going to buy AI and all my problems are going to go away, right? I mean, you have like two different, because we don't, and I think it has a little bit to do, but we don't really know what it is and how it's used in factories. So what I heard you say is what I call condition monitoring, right? I mean, condition monitoring to me is any type of inspection. I mean, you can go look, listen, feel, smell, you can do vibration monitoring, but basically we use AI. What you talked about so far was AI as a condition monitoring tool, right? Are there other uses? So is that the main use for AI? And of course there are other uses, but is that the main focus right now in industry you see is condition monitoring, or are there other usage?
Not only, look, AI is so broad, it's applicable pretty much in everything that we do today, starting from consumer, banking, hospitals, whatever you can think of, it's there, it's happening in industrial. I would say that in industrial, there are several applications. One of them, of course, is the predictive maintenance and condition monitoring. I see many companies which are using AI for supply chain optimization, spare parts consumption, even forecast, sales forecast, demand forecasts in the market. And there are many, many other aspects,
Right.
even in financial systems, control systems. Pretty much anything that you can think of is going to get affected one way or another.
Yeah, it seems like it, right? I mean, you can argue, it depends a little bit where you draw the line what AI is, but you can argue that Google is an AI. We use it, 10 times a day, however you see that. But specifically in maintenance, do you see that the main push right now, if you say like machine maintenance, electrical, mechanical maintenance, is typically mostly between condition monitoring? I've seen some companies trying to organize the information as far as getting all the information about the machine. So if I have a fault gearbox, you go on the internet, you go in the plant, you go in the sister plant, so you collect it. I've seen some trying to do that, but do you see in maintenance, is that about right, or is it something else you see kind of coming soon, or that people are using AI
Eh,
for, specifically in maintenance?
Again, I'm not the expert as I mainly focus on maintenance here. So I see mainly maintenance oriented companies and value propositions. I'm sure there that if you expand the eyesight a bit, you will see many more. But
Yeah,
from my world is mostly around predictive maintenance and condition monitoring using AI.
good. Good. Yeah, and that was my kind of impression too. So now let's say I'm a plant manager or maintenance manager, and I find this interview interesting. Say, this thing with AI sounds good because the DCS system is great, but I want to implement this. Where do I start? I mean, what's the prerequisites kind of thing? I mean, how do you go about this?
Yeah, that's good. Good question. AI needs data, right? And when we speak of data, there are mainly two types of data that we need in order to commission our solution. The first one is raw data, the sensor data, tags, what is usually recorded in the process historians. And we're talking about anywhere from dozens to thousands of sensors, whether the temperatures, the vibration, the pressures, anything that is part of the DCS and the control systems. That's one part of data. Usually, we like to train. It's better. It's more efficient. It's more. It's saving more time if we train the algorithms on historical data. So, good quality of data, sampling rate of, let's say, between 1 second to 5 minutes, something like that for 2 years is good. The second type of data that we need in order to commission and train the algorithms are some examples of historical failures. So in order to make them, I mean, there's few methods. I don't want to get too technical, but there are the supervised approach for AI and the unsupervised approach, where supervised means that a human helps the algorithms by providing them some examples of what they need to look for. An unsupervised method means that the computer, the algorithms will need to decide by themselves. They don't know exactly, they're not guided by a human what to look for. So going back to your question about prerequisites, historian with historical data, raw sensor data, and then failure log examples. There too, it should be mostly the unplanned events rather than the planned maintenance that are of interest.
Right. So in a typical plant that I go to and visit, I would think that typically we have the data we have is typically maybe vibration data, maybe temperature data. There may be some others, but most of the other data is somebody going with an infrared camera, once a month or once every 6 months. So that's not really helpful. I mean, I guess you could, in theory, use those, but you really want the online data, right? So
Yeah.
so maybe I'll start with my critical equipment where I actually have a vibration sensor, a temperature sensor. And the tricky part that I struggle with is I call it the failure developing period. The failure developing period, from the time we have let's say the temperature starts rising like you described until we actually have a failure, that time period can be really hard to catch. And I'm wondering,
Yeah.
it could be tricky for people to kind of catch that data. I don't know how many actually have that data today.
Yeah, no, that's good. So first of all, especially in the process industry, we see pretty much in every customer that we go to that they have a process historian recording historical process data. Whether it's in a good sufficient amount and sufficient sampling rates, it's a different discussion. Usually that's the case in the process industry. Now, why did we, when I say we, when we were a small company in Israel, as I said, Presenso, why did we go and partner or accepted the offer that SKF made to acquire Presenso? One of the gaps that we had being a software company or a data-driven company, I would say, a data-driven solution, one of the gaps that we had is that we had no idea about what the machines are and what they're doing and how are they operated. So we could have provided a customer with very good alerts, though this is where we end. This is where the customer, the process engineers needs to take the alert, to take the report and start doing their deep investigation about what's behind it. SKF, on the other hand, today we're experts in rotating equipment, in bearings, 100 and 15 years, I think, of engineering knowledge that has been accumulated. And what we're doing today is exactly bundling and hybriding, I would say, between the old data-driven solution with the expertise, with the subject matter expertise that we're now slowly incorporating into the AI.
Mm-hmm.
So we're hybriding data-driven with expert knowledge. You mentioned, you're correct, many assets are not online. So in the time intervals of between an inspection, one inspection to the other, a failure could evolve. And for that, again, as SKF, we have solutions. We have low cost, online, wireless vibration sensors that could be easily deployed and connected. So you have the AI analyzing the process data, vibration data coming either from walkarounds every week or every month or every quarter, vibration data coming online every minute or every day, and also the subject matter expertise of SKF of how to analyze the data and capture the value and the insights from it. So that was a long answer to your question, but yeah, we see the transition from walkarounds inspection once a quarter to online systems. COVID, by the way, we see that it helped accelerate this transition. And eventually this is where we're heading, right? And if you look 3-5 years into the future, remote, online, cloud.
Yeah, for sure. Yeah. You start seeing that. Well, for you, people may watch this in a couple of years. We're in early 2021, and COVID is hopefully slowly coming down, but we don't know yet. We'll see here. Yeah, but you really change. I mean, just this kind of interaction. We didn't. People used to call me and say, "Hey, let's do a sales call," and I will travel to God knows where.
Yeah, yeah.
2 days later, you come back, and instead of just having a meeting like this to start. But I think that's changing, and technology is changing. Very interesting. So SKF now, do you work mostly with machine condition monitoring when you use the AI, or are you also getting into the process, meaning looking at the process, I assume? So can you talk a little bit about that? Because I this is just in my head, but I'm thinking if I put in AI in one of the plants that I typically work in, I would probably find a little bit more process issues because there's just more sensors and more data there. So I'm thinking, am I right or am I on the wrong
Yeah.
track?
Look, eventually there are different types of failure modes. Some of them could be captured both by looking at the vibration and the process data, some of which could be only captured using vibration, and some of which could only be captured by using process. So we are utilizing, this is why we call it the hybrid. So it's like looking at the same asset from different angles with different binoculars. One is the vibration aspect. So we look at the vibration data. Usually it's mostly around the rotating shaft. And then another set of algorithms is looking at the process data in an effort to do two things. One, capture additional failure modes and predict additional failure that vibration is not always there. It's not always reflected in the vibration. And two is to contextualize one by the other. What I mean by that, if a vibration analyst sees an abnormal behavior in the vibration, today this is their scope. They're limited to the vibration data. But if they now can put the vibration data together with the process data, they could easily see that, yeah, the speed or the load of the motor increased 2 times. So you see the effect in the vibration. These kind of contextualization, which is important in order to get the holistic view of the asset.
Yeah. I noticed. I actually, that's a. I need to. I can't mention the company here, but there was a process industry company that I recently talked to that heavily have invested in AI, and they said they see a lot of those relationships. They have a pump that's cavitating. They were telling me the other day, and the reason was a tank that was going a low level that was an eighth of a mile down the road, but they saw it immediately. Before they would have found it too, but it would take
Yeah.
them probably a week to find it. But they saw it immediately because the AI connected the two and just told them, look, this is because you have a low volume, low
Yeah.
level in this tank. That's it. The pressure's low.
So I can give you a parallel example of a customer that we work with, and they have four gauges for forgot the name, young module. Uh, Anyhow, four gauges measuring pretty much the same thing at the same area to get different readings of pretty much the same thing. And then they saw in our system that we were able to find a correlation between three of them. So they told us, look, your system, you guys made a mistake because there are four who should be correlated, not only three. So we said, okay, let's dive deeper into the data and see what's going on. And then we saw that the fourth sensor, the fourth gauge, it's strain gauges, the fourth strain gauge was supposed to be measuring very close values to the other three, was completely out of calibration. So this is why it wasn't picked up in the correlative group. And they knew that they need to go and replace the sensor, recalibrate it, whatever, but they saw that something is not working as it's supposed to be. And yes, one of the what we've discussed previously was the anomaly detection when we gave the description about the temperature that's slowly drifting and rising up. If we take this temperature and we take 50 other assets, 50 other sensors in that process, we could detect, and we have examples of it, anomaly in the temperature, a day later an anomaly in the pressure, or 2 days later an anomaly in other metrics or other sensors, and you see the sequence of events, how it manifests itself in the data. So the first layer is anomaly detection, detecting the abnormal behavior on a sensor level.
Mm-hmm.
On top of that, it's the pattern detection or correlation detection to see how one event affects the other and eventually cascading into a potential failure.
Right. Yeah. So it seems like this to be successful. What I hear, you kind of have to do this in joint venture with operations and maintenance if you're going to get the full effect to kind of see the process, meaning operations are typically main guys for the for the process, maintenance, for the equipment. So to get the full benefit, you really need a partnership approach here and a holistic approach, not just measuring vibration. It's not the vibration department that installs AI, right?
Yeah.
It's a plant effort. Is that
Yeah.
correct?
And I would add IT department because data needs to be streamed, right? And along the way, the 6 years of the company, we actually took the time and written a book, a handbook, like a guide for Industry 4.0 implementation. And one of the topics is how it's really a cross-organizational effort. Uh,
Right. Yes,
uh,
and I saw that book. Let's talk about that. How can people get their hands on it? I read through it. I think it's a very practical manual. If people are interested in that book, how can they find it? Because I thought it was yourself and I believe Avi that wrote it. And
yeah, it was four of us, David, Avi, and myself. You can find it online on Amazon,
okay,
Uptime Magazine. Yeah, it's
so
available online. It's a presentation I give that summarizes or presents this startup that we were. And here's the book. So Maintenance 4.0 Implementation Handbook.
okay,
Again, available on Amazon online and also on Uptime Magazine.
right. That time the
Yeah.
reliabilityweb.com.
Reliability Web. Yeah, that's what
They
I mean.
have a
Sorry.
bookstore there, I believe it is. Yeah, great. Um, So when we implement this, what do you see as you had mentioned some of these things before, but what do you see as the biggest problems people run into? I see questions here around, I don't, maybe guys are sitting around looking at this saying, well, I don't have that many sensors. I mean, not sure if I have the right data. What are the problems you typically see when people want to implement AI?
Yeah, so problems usually it's the data, and even if it's there, it's not always easy to access. It's not always well organized. So we have the tools, and we can provide the consultation also on how to uh, step up when it comes to the data. We have customers that it's not it's a journey, and we have customers that we started a project and we saw, listen, with this kind of data we cannot provide you much value. Let's stop for a second. Let's start a process of 6-9 months to fix the data configuration, the data retention configuration, and we're doing it together with actually big customers, one now in the mining industry. So it's a journey. Another gap or another problem, I would say, it's a gap in expectations. Some people think AI and they think that AI is going to solve all their problems. That's not the case. AI, and many times the term is abused and being used to everything and anything, and AI has its limitations. One of them is the data, and as I said, sometimes people are expecting all their problems solved, plant running smoothly 100% of the time. I believe we'll get there, but it's still not the case. So one is the technical problem of data integrity. The second is I wouldn't say marketing, but the over expectations from such solution. It's a journey. It's not an off-the-shelf solution that will fix your problem tomorrow. It's a journey.
Right. Yeah, because that's what we see a lot from being a consultant in the industry. We simplify maintenance by saying, it's kind of comparison. In the 70s, we listened to bearings with a screwdriver, wouldn't stick. Now we have vibration analysis, so we find out 5 weeks earlier, which is great, but we still have to fix the bearing. We still have to change it out, and that AI is not quite there yet. We don't have a robot that goes in and pull out the bearing and change the bearing. Somebody has to fix it. So if we just let all these problems accumulate in the backlog and we don't fix them because we want to save money and say, look, well, I thought AI is going to solve everything, I don't want to fix my problems, well, they're still going to break down, right? So
Yeah, and it's not just that. I think AI could be very helpful. And again, going back to why we partnered and accepted SKF's offer to be acquired is also because we saw the need in the market for not only predictive maintenance, but prescriptive maintenance. So not only alerting, predicting the event, okay, you're going to have the pump is going to fail in 4 or 5 weeks, but also what is the root cause and what's the best corrective action to take. And as a software company, we didn't have this information. We didn't have this knowledge. As SKF, we're able, and again, it's work in progress. We're going to get there and perfect it as we progress. But eventually, the goal is to provide some prescriptive guidance together with every predicted failure alert.
right.
Eventually, someone will need to fix it. Yeah, these are machines. They need to be maintained.
Absolutely. Right. We're getting towards the end here, but I have a couple more questions. One thing is a little bit about sensors. I hear a fear about some saying if we get into AI, we're gonna have to buy, 1 billion sensors, and sensor temperature vibration was down to, they're 5, 6, $700, but I start seeing these sensors coming down quickly in price. But what's your take on that? Obviously we're going to have to put sensors on critical equipment. They're coming down in price. Do you see that's an issue, or do you?
I actually see it as an opportunity. First of all, again, when you look at the processing industry, you have tons of sensors already installed. I mean, the plant cannot run without them. They're part of the control system as it is, and usually it's a good place to start with the existing sensors. Along the way, and again, this is also something that we do as part of the consultation process. Along the way, if you see if customer and us as a service provider agrees and understands that additional sensors could be added, then it's not instrumenting the entire plant from scratch. It's adding a vibration sensor here or there, or temperature sensor. So it's not restructuring the entire control system of the plant. And also another point, another mega trend, so to speak, is that hardware is becoming cheap. Sensors, connectivity is becoming cheap. In some cases, I see sensors at I wouldn't say a dime a dozen, but I do see sensors much cheaper than what you probably used to see in the industry in the last decade or two. So it's
Good.
there, it's happening again.
Right. Do you see any other infrastructure problems? I mean, there's a lot of data flying around. I mean, in plants, do you see that's an issue? I mean, are there other like maybe not direct AI issues, but I'm just talking infrastructure with networks and all that. How does that
Uh,
look?
Yeah, first of all, there are always the remote sites where they depend on either satellite or different types of connectivity, which is not uh, land-based or internet-based. So there are some issues there. Also looking at maritime, which is also part of the industries that SKF serves. And another thing I would say is data in these plants, which are somewhat more advanced with their IT infrastructure, we do see siloed systems. So sometimes it's hard to gather all the data, the raw sensor data from the process, from the DCS, and the failure log from the maintenance and the work orders that have been put into the system. So you see very siloed systems, not communicating between them, not able to share data between themselves. And there too, we see great movement and companies evolving to kind of gather all these different data sources and place them in one data lake, which is easy to interface with. So it's also a movement and a trend in the market right now.
Yeah. Okay. Well, great. Well, we really appreciate your time, Ethan. And if somebody would like to talk to you and get a hold of you, we'll display that information here on the screen. We have your information. You let me know who to contact, and if somebody want to talk to SKF about AI.
Yeah, you have the contact. This would be Avi, who leads our marketing. He's the first and best point of contact. You have his email in our correspondence, so feel free to place it on the screen here.
Yeah.
And whoever wants to get in touch,
Okay. Very
feel free
good.
to reach out.
Great. Well, I really appreciate your time, Ethan. It's getting later there, and I hope you noticed my beautiful background here from one of my visits in Israel. It's Dead
Oh,
Sea,
Dead
right?
Sea.
It's a
Yeah,
Dead Sea. It's one of the companies down there. So
nice.
of course, the first day they take me up as high as possible, see if I can take heights. So I got to take that picture. Anyways, we really appreciate it, Ethan, and best of luck to you going forward.
Thank you, Torin. Hopefully it was interesting and beneficial to you and your audience and your customers and partners. Thank you.